Welcome to www.happynumbers.org. Today's lesson is solving algebraic equations using subtraction. In the last lesson we solved algebraic equations and all of them involved addition, and we used the inverse operation of addition. We know the inverse of the opposite operation of addition is subtraction. Well, now here, the problems that we're going to work with, we're going to have to use the opposite of takeaway or subtraction, which would be the opposite is addition. Now, the rules remain exactly the same no matter whether we're doing addition, subtraction, multiplication, or division. We want to get the unknown or the variable on one side of the equal sign and all the number on the other side. And the way we do that is by doing the inverse or opposite mathematical relation. Let's take a look at this problem. X minus 7 is equal to 4. Well, I have to get x by itself, so I need to get rid of this negative 7. Well, I know that the inverse operation is positive 7. And I know that if I do, I can do whatever I want to one side as long as I do it to the other side. So now I have x, and when I combine a negative 7 and a positive 7, I get 0. So x equals, and now when I combine a positive 4 and a positive 7, I get 11. So I've solved for x, and x is 11. Let's go back to our original problem. X minus 7 equals 4. And I'm saying that x is equal to 11. So 11 minus 7 equals 4. Well, 11 minus 7 does equal 4. So 4 equals 4. So our solution is correct. So again, I had a negative 7 here, so I used the opposite or inverse relationship to get rid of it. I used a positive 7, and I know that if I do something to one side, I must do it to the other side. Okay, let's take a look at another problem here. Let's try this one. Y minus 9 equals 13. Well, the process is exactly the same. I have to get the y by itself. To do that, I must get rid of this negative 9. So I use the inverse, which is a positive 9. And if I put positive 9 on this side, I must put positive 9 on this side. Now I have y. Now when I combine negative 9 and positive 9, I get 0. So y is equal to 13 combined with positive 9 gives me 22. And let's go back into our initial equation and substitute. Y, which we're saying is 22, minus 9 is equal to 13. Well, if I take 9 away from 22, I do get 13. So 13 equals 13. So our solution that y, the unknown y, is equal to, we found out that it's equal to 22, is correct. Excellent. Well, I'm going to put a couple of problems up for you now. Let's have you work that one, and by the way, this, I don't want to confuse you, this is a z, and that's a 2. Okay, so put your video or DVD on pause, work those problems, and then turn it back on again. Let's take a look. Y minus 4 is equal to 8. I have to get y by itself. So I have negative 4, so if I put a positive 4, I'm sorry, I don't want to confuse things. If I put a positive 4, I know that these will cancel each other out, but if I put a positive 4 here, I have to put a positive 4 there. So I get y, a positive and a negative 4 cancel each other out, equals 8. If I combine 8 and 4, I get 12. Let's see if that's correct. Let's go back to our initial equation. Y minus 4 equals 8, and we're saying that y is equal to 12, so 12 minus 4 equals 8. And 12 take away 4 is 8, so 8 equals 8, so we are correct. Okay, let's go over to the next one. Z minus 2 equals 9. Well, I have to get rid of this negative 2, so I know I can put a positive 2. I can use the inverse relationship, the inverse mathematical relationship. If I put positive 2, I put positive 2 here. I don't need to write the positive because I know it's positive. So I have Z, and if I combine negative and positive 2, they go away. Z equals 9 plus 2, which is 11. Let's substitute back in our original equation. Z, which we're saying is 11, minus 2 equals 9. Well, 11 take away 2 is 9, so 9 equals 9, so our solution is correct. A couple more problems. Now you'll notice here we're using the inverse of subtraction. We're using addition to get rid of the number. Let's take here, a minus 21 equals 34. So try that one, and try b minus 16 equals 49. So put your video or DVD on pause, work those problems, and then turn it back on again. Okay, well, we have a, and I have to get a by itself on one side of the equal sign, and all the numbers on the other side. Well, I have a negative 21, so I can put a positive 21. And if I do that on this side, I have to put a positive 21. I don't have to write the positive because I know it is. And now I combine. So I have a, if I combine negative 21 and positive 21, that goes away, equals 34 and 21, which would be 55. And if I go back to the original equation and say a, which is 55, minus 21 equals 34. And if I had 55 and I took 21 away, 5 take away 1 is 4, 5 take away 2 is 3. So 34 equals 34, so I'm absolutely correct. Let's try here. B minus 16 equals 49. I have to get B by itself. I have a negative 16, so I'll use the opposite or inverse relationship, which is positive. If I do it on this side, I must do it here. I don't need to write the positive. And then I have B. If I combine the negative and positive 16s, they go away, equals 49 plus 16. That would be 9 and 6 is 15. Carry the 1 would be 65. If I go back to my original equation, B, 65 minus 16 equals 49. Well, let's see, 65 minus 16. Have to borrow a 1, that's 5. So 15 take away that is 9. 5 take away 1 is 4. So 49 equals 49. So my answer is correct. Excellent. Well, I have two more for you. And again, this is an example of using the opposite of subtraction, which is addition, to get rid of our variables. Let's try this. X minus 12 equals negative 6. Now don't be blown away by that. And C minus 14 equals negative 23. All right. Put your video or DVD on pause. Think carefully through this. You know how to do this now, though. And then turn it back on and we'll work it. All right. X minus 12 equals negative 6. I have to get x by itself, and I have a minus 12, so I'm going to put a positive 12 here, which is the inverse relationship. So I have to put a positive 12 here. Whoop. 10 minutes is up. I may go a little over here, but that's all right. Bear with me. Okay, so now when I combine, I have x, and the positive and negative 12 goes away, equals negative 6 plus positive 12 would give me positive 6. So we're saying our solution is positive 6. Let's go back to our initial equation. X, which is, we're saying is positive 6 minus 12 equals negative 6. Well, if I combine a positive 6 and a negative 12, I do get a negative 6 equals negative 6. So our solution of 6 is correct. Let's try this problem here. C minus 14 equals negative 23. Well, I have to get C by itself, and I have a minus 14, so I'll put a plus 14, and I know I have to do exactly the same thing to this side. When I combine them, C, these two cancel each other out, equals negative 23 and a positive 14 would give me a negative 9. Let's go back into our initial equation and see if this is so. C, which we're saying is negative 9, combined with a negative 14 is equaling negative 23. Well, if I combine a negative 9 and a negative 14, I have a negative 23 equals negative 23. So our solution is correct. Well, excellent. Well, so what we have done here is we have used with solving equations in terms of addition, and now we've used the opposite operation and we're working with when we have minus, and we're using addition as the inverse opposite relationship. Excellent. Well, next time when we continue, we'll be solving equations using the inverse of multiplication, which is division, but we'll see how that works. See you next time.